this video, we are going to be solving questions on Southwest Region Amok Chemistry Advanced Level Paper 1 2022. If you haven't subscribed, consider doing so that you won't miss any of the future videos. Let's go right into the video. Question number 1. A molar solution is... So what's a molar solution? This is one which contains 1 mole of solute dissolved in 1 dm³ of solution. Option A says it is 1 mole of solute dissolved in 1 dm³ of solvent. It's not solvent, but it is in solution, 1 dm³ of solution. So if we are talking about solvent to be 1 dm³, you realize if you want to add anything to 1 dm³ of solvent, the final solution will likely increase, let's say, to 1001 or 1002 cm³. So it is better to use solution because it is already molar, exactly 1 dm³, making our option to be C, which is the best. Question 2. Identify the hybridization of carbon in the following molecule. What is hybridization? This is the mixing of dissimilar orbitals to form new hybrid orbitals of similar energy. So organic compounds undergo hybridization in the carbon atoms. So hybridization can be sp, sp2 or sp3 depending on the number of p orbitals taking part in hybridization. So the p orbital or the p subshare is divided into 3 orbitals, and the p orbitals are px, py, and pz depending on their orientation in space. So when only 1 p orbital is present, it is sp. When there are 2, it is s2p. When there are 3 p orbitals, it is sp3. And for sp3 hybridization, it means that an s orbital is combining with the 3 orbitals to form a general hybrid sp3 hybridized molecule. So when all the 3p are involved, we now talk about sp3. For sp2, it will be the s orbital taking only 2 of this, leaving out 1 p orbital unhybridized. And for the unhybridized p orbital, it is that which forms a pi bond. So therefore, when there are all hybridized orbitals, they give rise to sigma bonds, and they are all single bonds. Now, an unhybridized orbital will give rise to a pi bond. Since for sp2 we have pz, which is unhybridized, it gives rise to a pi bond. So in it will be a double bond from which one is sigma and another is pi. Now for sp, it means that we have s and only 1 p orbital, leaving py, pz unhybridized. The 2 p orbitals that are unhybridized will form 2 different pi bonds, and the general carbon atom will have triple bonds with 2 pi bonds and 1 sigma bond. So from this compound, carbon 1 has all single bonds, so it should be sp3 hybridized. Carbon 2 has a double bond, and we say for a double bond it is sp2, therefore it is sp2. Carbon 3 is sp2. Carbon 4 also has a double bond, and it is sp2. Therefore, we have our best option to be A. Question number 3. When a solution of potassium iodide is treated with silver nitrate 5 solution, it forms A. A yellow precipitate insoluble in aqueous ammonia. B. A cream precipitate insoluble in aqueous ammonia. C. White precipitate soluble in aqueous ammonia. D. A pale yellow precipitate soluble in aqueous ammonia. For the test of the halide, the iodide is tested by the formation of silver iodide. When silver nitrate reacts with the iodide, a yellow precipitate which is insoluble in aqueous ammonia will be formed. For the bromide, it will be a cream precipitate. For the chloride, it is a white precipitate. So therefore, since we are talking about potassium iodide, it is a yellow precipitate which is insoluble and making our option to be A, which is the best answer. Question 4. Which of the following chlorides neither ionizes nor hydrolyzes in water? For the group 4 chlorides, carbon tetrachloride is said to be insoluble in water because it doesn't have low-lying d orbitals, which can form intermediate with water molecules. For the rest, they are soluble because they contain low-lying d orbitals to form intermediate. So only tetrachloride is insoluble in water and does not ionize, making our option C to be the best. Question 5. The correct formula of an ozo acid of chlorine, which has an oxidation state of +3 and +7, are respectively. So by observation from B, if I look at this ozo acid and I calculate the oxidation state of chlorine, what I'm going to have, I can call chlorine X, and hydrogen is 1, oxygen atoms are 2, and the valency of oxygen is -2. So we're going to have 1 plus X plus -4, since there are 2 oxygen atoms, equal to 0, since the overall charge is 0. Making X such that the formula will be +3. And then for the corresponding ozo acid for +7, we will calculate hydrogen is 1 plus chlorine, which we don't know, X. There are 4 oxygen atoms with oxidation of -2, which will be +-8, equal to 0. 1 minus 8 is -7, therefore X equals +7, making our correct answer to be B. Question 6. Identify the compound that can exhibit stereoisomerism. What is stereoisomerism? It is one which occurs when 2 or more molecules have the same molecular formula and the same connectivity of atoms, but they differ in the spatial arrangement of their atoms in space. So stereoisomerism can either be geometric or optical. So for geometric, we have carbon to carbon double bond with different groups which can either be identical. For instance, we have this for cis and for trans isomers. For optical isomerism, they will always form mirror images where there is a species which is bonded to 4 different groups, something like this. So it will always form its mirror image on the other side. So what we are looking for is a species that is optically active, which has a chiral center. And if we watch closely, we are going to observe that D is our correct option, where this carbon atom is a chiral carbon bonded to hydrogen, OH, methyl, and the ethyl group. So the carbon atom is bonded to 4 different groups, making it to be optically active. Hence, it does exhibit stereoisomerism. D is our best option. Question 7. What is the coordination number of ion in the complex compound given? We have potassium, we have ion, the cyanide 6. So what is the oxidation state of ion? What we have to know is potassium has +1 and the cyanide is minus. There are 6 cyanide ions present and there are 2 potassium. So making ion to be X and knowing that the overall charge is 0, we can normally say potassium, since it is +1, will be now 2, since there are 2 of them, plus ion, which is X we are looking for. For cyanide, there are 6 of them and this minus is going to give us +-6, equal to the overall charge, which is 0. So we have 2 minus 6, which is -4. We have X minus 4 to be equal to 0, which implies that X will now be equal to +4. So the oxidation state of ion in this complex is +4. This complex name is potassium hexacyanoferrate 4, because we've calculated the oxidation state to be 4. It becomes hexacyanoferrate 4. So our best option is B. Question number 8. The general outer electronic configuration of the group 5 elements is, for the group 5 elements, they are called p block elements because the valence electrons are filling the p subshell. Now for group 5, what will be the outer s electron for group 5? The outer s electron for group 5 is ns2np3, where n stands for the quantum number. So an example of an element in group 5 is nitrogen. Nitrogen is in group 5. The electronic configuration of nitrogen is 1s2, 2s2, 2p3. Nitrogen is number 7, having 1, 2, 4, 7 electrons. So we realize that we have s2p3. It means that for each group 5 element, we will always have 2, 3. Only n is changing, which is the principal quantum number, increasing atomic number, but the valence electrons remain constant, making our correct answer to be B. Question 9. Which of the following D block metal ions forms colorless complex ions and compounds? So for the manganese, for chromium 3 and iron 2, they do form colorful compounds. It is only for copper 1 ion, which has a low charge density, which makes it to form colorless compounds, unlike its counterpart, which is copper 2 ions. Due to high charge density, it can be able to form blue complexes due to the presence of copper 2 plus of higher charge density. So copper 1 plus will form colorless compounds due to low charge density. Our answer is D. Question 10. Which properties account for the diagonal relationship between elements in the periodic table? For diagonal relationship, it arises due to similarity in electronegativity and atomic sizes of atoms. In diagonal relationship, we have elements arranged like this, of this magnitude. Let's say this is for the S block, where we have lithium, we have beryllium, here we have sodium, here we have magnesium. This is a diagonal, and it is said that lithium and magnesium show diagonal relationship, which means that they have similar chemical properties, and this arises due to the fact that they have similar electronegativity and atomic size, making our option C to be our correct answer. Question 11. Which statement describes bonding in hydrocyanic acid, HCN? So for hydrogen cyanide, we can write out the dot and cross diagram for the hydrogen cyanide to be something of this magnitude. So to write out the bonds, we realize that hydrogen forms 1 bond, the carbon and nitrogen will form 3 bonds, so that we have something HCN. So we have an electrostatic force between shared pair of electrons generally and the positive nuclei. This is the definition of a covalent bond. So our correct option here is D. Question 12. Which of the following is a property unique to group 4 elements? They say A. Variable oxidation. Variable oxidation is not unique for group 4 elements, it's rather unique for transition metals. B. Diagonal relationship, which is totally out of phase, has no relation. C. Hybridization, not true. We have D. Catenation. Catenation, we know, is predominant for carbon. We say it is able to form rings and chains. So the only difference between the catenation in carbon and in the other group 4 elements is that carbon can be able to catenate extensively, unlike the others which can only catenate mildly. Carbon can do so because of its ability to undergo hybridization. So it can form triple, single, and in fact it can form multiple bonds. So catenation is a characteristic of group 4 elements, but carbon is said to catenate extensively. So carbon is not totally different from the other element by its ability to catenate, because other elements do catenate in a smaller proportion or in a mild amount. So D is our best option. Question 13. Which of the following elements has the largest second ionization energy? Second ionization energy simply means first electron has been removed from each of the atoms, and we are now to remove the second electron. So we have for sodium has one valence electron. We have for potassium, which has one valence electron. We have for magnesium with two valence electrons. We have for calcium with two valence electrons. And we realize that for sodium and potassium, sodium has atomic number 11 and potassium has atomic number 19. Magnesium has atomic number 12, calcium has 20. Now, we are talking about second ionization energy. It means that for the first ionization energy, this electron will be removed, as well as this one for potassium will also be removed. Now, for magnesium, first ionization energy, this one will be removed. For the first year, this one will be removed. And to have the second IE now, we come back to sodium. Since it had only one valence electron, it means that the second electron has to be removed from the inner shell, which is having 8 electrons. Same for potassium. Now, for this, since it has 1 electron each that is left, the second IE, the valence electrons now will be completely removed for magnesium and calcium. Now we are comparing between potassium and sodium. Which of them will require a higher second IE? Automatically, it has to be for sodium, because sodium has a smaller atomic size compared to potassium, since potassium has a higher atomic number. Therefore, second IE for sodium is greater than that for potassium, making A to be our correct answer. Question 15. Bromine can be produced from the following reaction. We have the bromide reacting with the bromate to give us bromine and water. Which two methods should be used to monitor the rate of the reaction? Now, for you to identify a method that has to be used, you look at the expression and you look at what is changing, all the different reagents, products and reactants. If I look at bromine here, I realize that the color of bromine is reddish brown. It tells me that as the bromine is being produced, I expect to be seeing a reddish brown color being appeared in the course of the reaction. Therefore, as a color is being produced, there is going to be a change in color intensity. So I can use now a colorimeter to measure the change in color intensity of the bromine that is produced. Now, I also check what other parameter can be measured from here. Conductivity can be measured due to difference in charges. I look at the right hand side of the equation. I realize that there is an overall charge of 0. I look at the left hand side of the equation. There is a particular charge, negative, negative, positive, with an overall of negative. So there is a difference in charge. If there is a difference in charge, conductivity can be measured using a conductimeter, and the process is called conductimetry. So be mindful of the question. They can also ask you what parameter can be measured. The parameter now is the exact quantity you're measuring. Are you measuring color intensity? Are you measuring pressure? Are you measuring the volume of gas produced? Are you measuring conductivity? And so on. So what we need here is a process called colorimetry and conductimetry. So we have conductimetry and colorimetry, making C to be our best option. Question 16. Analysis of 2.2 grams of a compound of phosphorus and sulfur show that it contains 1.24 grams of phosphorus. The empirical formula of the compound is... So let's see how we can handle this problem. So we have phosphorus and sulfur. And for phosphorus, we have 1.24 grams. For sulfur, we don't have, but we have the total mass of the compound, which means for sulfur, it will be 2.2 minus 1.24, which is going to give us 0.96. So this will be 0.96. Now to calculate the empirical formula, we will divide all through by their relative atomic masses. That of phosphorus is 31, and here we have 32. And dividing this, you have 0.03, and dividing this, we have 0.04. And now what we do next is So what we do now is we divide by the smallest mole ratio, which is 0.03, divide it by 0.03, so that we have 1 here and 3, 0.33. Now this has no equivalence, so we are going to multiply all through by a factor of 3, so that we are going to have here 4, 3. Now our empirical formula is going to be P4S3, and as we have that, our answer is going to be B from here, P4S3. Question 17. Identify the particle X in the nuclear reaction by giving its mass number and atomic number. So for the nuclear reaction, we are interested at having the mass numbers on the left hand side to equal those on the right hand side, and the atomic numbers on the left hand side to be equal to the atomic numbers on the right hand side. So let us write out the expression. So we are saying that the mass numbers for the equation, so we are saying that for the equation to be balanced, the mass numbers on the left hand side should be equal to the mass numbers on the right hand side, which means that I have 4 plus 14 to be equal to 1 plus A. If I solve for A, it means that I'm going to have A to be equal to, this is already 18. I send this one the other way, it becomes 17. So A equals 17. And I look at the second one for the atomic numbers. I have 2 plus 7 to be equal to 1 plus B. If I make B the subject of the formula, B is going to give me, this is 9 minus 1, 8. I have 8. Therefore, I have 17 and 8 respectively. And if I check that, I'm going to see that our correct option is A, 17 and 8 respectively. Question 18. What volume of 12 molar HCl is required to prepare 75 milliliters of 3.5 molar HCl? This is just dilution, where we say that for a particular solution, number of moles before dilution equals the number of moles after dilution. And in solution, number of moles is given by molarity times volume. Therefore, if we are talking about before and after dilution, it means that we have the concentration before dilution to be 12, and the concentration after dilution is 3.5, where we're going to say M1V1 equals M2V2. So therefore, our M1 is 12, V1 is unknown, M2 is 3.5, V2 is 75 milliliters. So we are looking for V1, where V1 is going to be equal to M2 V2 divided by M1, which will be equal to M2 3.5 times V2 75 divided by M1, which is 12. If we punch that, we are going to have 21.875 milliliters, which is approximately 21.9 milliliters. And our correct answer here gives us A. Question 19. Which of the following will change the value of Kc? The physical factor that really changes the value of Kc significantly is temperature. Temperature changes both the enthalpy and the entropy of a reaction. However, other factors like introduction of catalysts, pressure, and concentration do also affect the Kc, but predominantly, or the effects of temperature is most significant, since it greatly affects the enthalpy and the entropy of a reaction. So our best option is C, temperature change. Question 20. Predict the major products of the following reaction. We have phenol reacting with chloromethane in the presence of a halogen carrier, aluminum chloride. So phenol, the OH group in the phenol is electron donating. Thereby, it activates the ring by donating electrons, making the benzene ring more nucleophilic and hence more reactive. And the OH group will be auto-para-directing. Means that any second coming group can either be directed to the auto direction, to the auto, or to the para direction. So we're saying that if phenol reacts with chloromethane, we are going to have the product this and this, where this is 2-hydroxy-toluene and this is 4-hydroxy-toluene. Now this is the para, this is meta, this is auto, this is as well para, auto, meta. So we say that the electron donating group is auto para directing, while the electron withdrawing group, like the nitro group, is meta directing. So what we need to have, what we have as our product is this and this, which is hydroxy auto, we have auto hydroxy-toluene and para hydroxy-toluene, because we have the toluene on the para and here we have on the auto, making our option C to be the correct answer. Question 21. Why are scandium and zinc considered as D-block elements but not as transition metals? So the characteristic properties of transition metals is that they have partially filled d orbitals in their ions. So it means that scandium and zinc do not have partially filled d orbitals when they form ions. For scandium, we have the electronic configuration to be 3d0 4s0. When it forms an ion, for scandium we will have an empty d orbital for its ion, because it forms an ion of +3. Means that the normal electronic configuration argon 3d1 4s2. Now when it forms an ion, these 3 electrons are lost, leaving the d orbital empty, and since it is empty, it is considered not transition. Likewise, zinc, which is also considered transition because it forms an ion with a completely filled d subshare, so making it not to be transition. So we have zinc that forms zinc 2+. So the characteristic properties of transition metals is that they form ions with partially filled d subshare. So why should scandium and zinc not be considered as transition? We say A, they do not form color compounds. That's not a particular characteristic. B, they do not form ions or compounds with partially filled d orbitals. That is our correct answer, which is feasible, making it to be B. 22. The pH of a 0.01 molar solution of sodium hydroxide is, so this is a base. When you dissociate the base, we are going to have sodium ions and OH minus ions. What we are looking for is POH. So the POH for the alkali will be equal to negative logarithm of the hydroxide ion concentration, which will be negative logarithm of 0.01 molar. So POH will be equal to 2. But in neutral medium, we know that pH plus POH equals 14, which implies that pH of the solution now will be equal to 14 minus POH, which will be equal to 14 minus 2, equaling 12. So our pH for this is going to be 12, making B to be our correct answer. Question 23. Identify the element with the highest melting point. For the elements with the highest melting point, it is going to be silicon. Why does silicon have a higher melting point? Due to its giant covalent structure. Silicon has a giant covalent structure. That's why it has a higher melting point. Unlike boron, boron has, first of all, a smaller atomic size, thereby weaker covalent bonds. Carbon does have higher melting point than boron because at least it can form multiple bonds, single bonds, triple bonds, different covalent bonds, but they are still weaker than silicon. So silicon dominates all of them due to its structure, giant covalent structure, that it can be bonded covalently with 4 different silicon atoms, making D to be our correct answer. Question 24. The most suitable reagent for the conversion of ethanamide to methylamine is, once we see a reduction in carbon, here we have 2 carbon atoms going to 1 carbon atom, we think of Hofmann's degradation. And with Hofmann's degradation, we need a metallic hydroxide in bromine. So conversion of amide to amine, we are going to use bromine in potassium hydroxide or bromine in sodium hydroxide. Our answer is D. Question 25. Which of the following nitrate will decompose to give the nitrite and oxygen? For the nitrate of group 1, when decomposed like sodium nitrate, we are going to have their nitrite and oxygen gas evolved. But for the nitrate of group 2, when decomposed, we are going to have their oxide, nitrogen dioxide gas, and oxygen produced. So all group 1 nitrates except lithium nitrate will decompose to give their nitrite and oxygen. Since lithium shows a diagonal relationship with magnesium, therefore the decomposition of its nitrate will be similar to that of magnesium. So therefore lithium will be decomposed to its oxide, nitrogen dioxide, and oxygen, making our option A to be correct. Sodium nitrate will give its nitrite and oxygen. So that's the end for this video. If you found it helpful, don't forget to like, comment, and share with your friends. Thanks for watching.